Hello everyone. In this tutorial I will complete solving the exercises of lesson 4.2. We reach question number 12. Number 12 to 17, find the local extrema by using the second derivative test. Question number 12, f of x equal x to the power 4 minus 4x power 3 plus 2. Find the first derivative, f prime of x equal to 4x power 3 minus 12x squared. Set it equal 0 to find the critical point. Factorize by 4x power 2, x minus 3 equal 0. Either 4x power 2 equals 0, then x equals 0, or x minus 3 equals 0, then x equals 3. Find the second derivative of this function, 12x power 2 minus 24x. If double prime of 0 equal to 0 minus 0, 0, the second derivative test fails at this point. If double prime of 3 equal to 12 times 3 power 2 minus 24 times 3 equal to 12 times 9 greater than 24 times 3. The answer is positive greater than 0. Therefore, x equal 3 is local minimum point for this function. Question number 13, f of x equal negative bracket x minus 5 to the power 2. F prime of x equal to negative 2x minus 5 to the power 1. Set it equal 0. Then x equal 5 is critical point. F double prime of x equal to negative 2, then f double prime of 5 equal to negative 2 less than 0, then x equal 5 is local maximum point for this function. Question number 14, f prime of x equal to 2 over 3 x to the power 2 over 3 minus 1 negative 1 over 3 equal to 2 over 3 cube root of x. Set it equal 0, cross multiplication, then 2 equal 0, contradiction, there is no value of x, make this function 0. But if we set 3 square cube root x equals 0, then we get x equals 0. It is critical point for this function since it makes the derivative of this function undefined and it is within the domain of the function. Now find the second derivative of this function, 2 over 3 times negative 1 over 3 x to the negative 1 over 3 negative 1 negative 4 over 3 equal to negative 2 over 9 cube root of x power 4. F double prime of 0 at the critical point, it is negative 2 over 0 undefined, then the second derivative test fails to find the local extrema of this function. Then we need to check it with the first derivative test. Question number 15, f of x equals square root x power 2 plus 1. Find the first derivative, f prime of x equal to 2x over 2 square root x power 2 plus 1. Reduce 2 with 2 equal to x over square root x power 2 plus 1. Set it equals 0, cross multiplication, then x equals 0 is critical value for this function. There is no value make the denominator 0, therefore the only critical point is x equal 0. Find the second derivative of this function f double prime of x equal to the denominator square root x power 2 plus 1 times the derivative of the numerator 1 minus the numerator x times the derivative of the denominator 2x over 2 square root x power 2 plus 1 over denominator square root x power 2 plus 1 square x power 2 plus 1 equal to reduce 2 with 2, then square root x power 2 plus 1 minus x power 2 over x times x power 2 over square root x power 2 plus 1 over x power 2 plus 1 equal to find the common denominator for two terms in the numerator square root x power 2 plus 1 times square root x power 2 plus 1 x power 2 plus 1 minus x power 2 over x power 2 plus 1 equal to remove x power 2 minus x power 2 1 over square root x power 2 plus 1 times x power 2 plus 1 x power 2 plus 1 to the power 3 over 2. This is the second derivative of x. Find the second derivative at the critical point x equals 0, then 1 over 0 square plus 1 to the power 3 over 2, 1 over 1 equal 1 greater than 0, then x equals 0 is local minimum extrema for this function. Question number 16, f of x equal x plus 4 over x, f prime of x equal to 1 minus 4 over x2, x power 2, set it equals 0, then 4 over x power 2 equal 1, then x power 2 equal 4, then x equal negative positive 2. F double prime of x equal to negative 4x to the negative 2, 8x to the negative 3 equal to 8 over x power 3. Now find the second derivative at the critical point. F double prime of 2 equal to 8 over 8 equal 1 greater than 0. Then x equal to is local minimum point for this function. F double prime of negative 2 equal to 8 over negative 8 equal to negative 1 less than 0, then x equal negative 2 is local maximum point for this function. Question number 17, f of x equal cosine x minus x, f prime of x equal to negative sine x minus 1. Set it equals 0, then sine x equal negative 1. Then x equal sine inverse negative 1 or sine inverse 1 equal to pi over 2. The sign is negative in quarter 2 and in quarter 3 and 4. In quarter 3, x equal to pi plus pi over 2 equal to 3 pi over 2. In quarter 4, x equal 2 pi minus pi over 2 equal to 3 pi over 4. So the critical point is 3 pi over, 3 pi over 2. The second derivative, if double prime of x equal to negative cosine x, if double prime of 3 pi over 2 equal to negative cosine 3 pi over 2 equals 0, then the second derivative test failed. To find the local extrema for this function, we need to use the first derivative test. Question number 18, f is a function whose derivative is increasing. Sketch a graph of f for a when f prime of x less than 0, b when f prime of x greater than 0. If f of x equal to 1 over square root x, then the graph of this function is like this shape, and the derivative of the function is like this shape. This is f prime, this is f. The derivative of the function is increasing, as you see, and f prime of x is less than 0 since it is under x axis. For b, if we take f of x equal to 1 over square root negative x, then take this shape, and the derivative of it is like this. This is the function f, and this is the derivative. As you see, the derivative of the function is increasing, and also it is greater than 0 since it is over x axis. Question number 19. F is a function whose derivative is decreasing. Sketch the graph of f in these two cases when f prime of x less than 0, when f prime of x less than 0, f of x equal to negative 1 over square root negative x. The graph of take this shape, and its derivative, it is like this. This is the derivative of the function, and this is the function f. As you see, the derivative of the function is decreasing, and it is less than 0 because it is under x axis. For b, take f of x equal to negative 1 over square root x. Then the graph of this function is take this shape. Its derivative take this shape. This is f, and this is f prime. As you see, the derivative of the function is decreasing, and it is greater than 0 because it is over x. Question number 20. Sketch a graph of a function f that does not have a point of inflection at cf of c, even though f double prime of c equals 0. If we take f of x equal to x minus 1 to the power 4, then the first derivative of this function is 4 x minus 1 to the power 3. The prime of x equal to 12 x minus 1 to the power 2. Set it equal 0, then x equal 1 is critical point. And if we check the sign of the second derivative before and after 1, when x equals 0, when x equal negative 1, then the function is positive. The second derivative is positive. When the point greater than 2, 1, 2, also the second derivative is positive. Therefore, the function is always concave, and x equal 1 is not an inflection point for this point, and the graph of this point is take this shape. Question number 21, sketch the graph of f of x equal cube root of x. Identify the point of inflection. Is f double prime defined at the point of inflection? Let us see. F prime of x equal to f of x is x to the power 1 over 3, then 1 over 3 x to the negative 2 over 3. Then f double prime of x equal to negative 2 over 9 x to the negative 2 over 3 minus 1 negative 5 over 3 equal to negative 2 over 9 cube root of x to the power 5. Set it equals 0, then negative 2 equals 0, contradiction, there is no value, make the second derivative 0, but x equals 0, the function, the second derivative is not defined at x equals 0, since it makes the denominator 0, and it is in the domain of the function, therefore x equals 0 is a critical point. If we check the sign of the second derivative before and after 0, when x equals negative 1, then negative over negative positive. When x equals 1, then the sign is negative. Therefore, x equals 0 is an inflection point. But the second derivative, it is not defined at 0. Graph of this function is take this shape. Before 0, the graph is concave. After 0, the graph is convex. 23, a small aircraft starts its descent from an altitude of 1 kilometer west of the runway. Needed A, find the cube function f of x equal ax power 3 plus bx power 2 plus cx plus d that describes a smooth glide path for the landing on the interval negative 4, 0. This is the graph of this function, of this question. This is the plane of altitude 1 kilometer, 5 kilometer, west of runway. This is the point 0, 0. This is negative 4, 1. Now, since 0, 0 is on the graph of the function, then it is satisfy the graph, the function of this graph, f of 0 equal to 0 equal to 0 plus 0 plus 0 plus d, therefore d equals 0. Also, 0, 0 is local minimum point for this point, then f prime of 0 equal to 0. F prime of 0 is f prime of x equal to 3ax power 2 plus 2bx plus c. F prime of 0 equal to 0 equal to 0 plus 0 plus c, then c equal 0 also. Now, negative 1, 4 belong to the graph, is on the graph of the function, then it is satisfied the function. Therefore, f of negative 4 equal 1 equal to a negative 4 power 3 plus b negative 4 square plus 0 plus 0 equal to negative 4 to the power 3 negative 64a plus 16b. This is equation 1. Also, negative 1, 4 is a local maximum point for this function. Therefore, f prime of negative 4 equals 0. F prime of negative 4 equal to, this is f prime of x, 3a times negative 4 square plus 2b times negative 4 equal to 0. Then negative 4 square, 16, 16 times 3, 48, a minus 8b equal 0. This is equation 2. This is equal 1. Now solve these two equations, 1 and 2, to find the value of a and b. Negative 64a plus 16b equal 1 and 48a minus 8b equal 0. Multiply the second equation by 2, then it will be 48 times 2, 96, a minus 16b equal 0. Add these two equation, negative 64 plus 96, 32, a equal 1, then a equal 1 over 32. Substitute the value of a in the second equation to find the value of b. 48 times 1 over 32 minus 8b equals 0. Then 8b equal to 48 over 32. b equal to 3 over 16. Then the equation will be f of x equal to ax power 3, 1 over 32 x power 3 plus b 3 over 16 x square plus 0 plus 0. This is the answer of needed b. When would the plane be descending at the most rapid rate? The rapid rate happened when f double prime of x equal 0, because the function changed, the graph of the function changed from convex to concave. Therefore, we will find the second derivative of this function first. F prime of x equal to, find the derivative of this function, 3 over 32 x power 2 plus 6 over 16 x, reduce 6 with 16, divide by 2, 3, 8. Now, the second derivative of the function is 2 times 3, 6 over 32 x plus 3 over 8. Set it equals 0 and find the value of x. 6x divide by 2, 3, 1, 6. Then 3x over 16 equal to negative 3 over 8 then x equal to negative 3 over 8 times 16 over 3 equal to, reduce 3 with 3, uh, 8 with 16 equal to negative 2. Therefore, x equal negative 2. Therefore, the fastest landing will be a distance of 2 kilometers far away from the question aircraft. Number 24. Prove that if c is a cubic function with three distinct real zeros, then it has a point of inflection whose x-coordinate its average of the three zeros. Let the function is c of x equal to k, and the distinct zeros are a, b, c, x minus a, x minus b, x minus c. Open these brackets, c of x equal to x times x power 2, x times b, negative bx, minus xa, or ax, plus ab, times x minus c, equal to k, x power 2 times x power 3, minus c x power 2, minus b x power 2, plus c bx, minus a x power 2, plus acx, plus a bx, minus abc. Now, differentiate this function k, 3x power 2 minus 2cx minus 2bx plus cb minus 2ax plus ac minus a or plus ab. The second derivative is c double prime of x equal to, differentiate this function, 6x minus 2c minus 2b minus 2a equal to, set it equal 0, then 6x minus 2c minus 2b minus 2a equals 0, then 6x equal to 2a plus 2b plus 2c, then 6x equal to, factorize by 2, a plus b plus c, then x equal to 2a plus b plus c over 6 equal to a plus b plus c over 3, which is the average of the three zeros of this function. And it is the point of inflection because it makes the second derivative 0. Question number 25 to 28, true or false? The graph of a cube function has exactly one point of inflection. This statement is true because the second derivative of this function, of the cube function, is a linear function, and a linear function has one root. The graph of f of x equal 1 over x is convex when x less than 0, concave when x greater than 0, and has one point of inflection at x equals 0. This statement is false because x equals 0, not in the domain of the function, and it is not an inflection point for this function. 27. If f of f If f prime of c greater than 0, then the graph of f is concave at x equals c. Also, this statement is false because if we take f of x equal to x power 3 plus x, then f prime of x equal to 3x power 2 plus 1. And if double prime of x equal to 6x, set it equals 0, then x equals 0 is critical point. Find the sign of the second derivative before and after 0. Before 0, when x is negative 1, the second derivative is negative. When x is greater than 1, the second derivative is positive. And f prime of negative 1 is greater than 0 because 3 times negative 1 squared, 3 plus 1, 4, greater than 0. But at x equal negative 1, the function is convex and not concave. Question number 28. If double prime of 2 equals 0, then the graph of f has a point of inflection at x equal 2. This statement also is false because we take f of x equal to x minus 2 to the power 4, then the first derivative f prime of x equal to 4x minus 2 to the power 3. And the second derivative f double prime of x equal to 12 x minus 2 to the power 2. Set it equals 0, then x equal to is critical point. If we find the sign of the second derivative before and after 2, when x equal 1, 1 minus 2 negative 1 square, the second derivative is positive. After 2, 3, 3 minus 2, 1, also the function is positive. Therefore, the function is concave everywhere, and 2 is not point of inflection to this function. See you next lesson.